Welcome to Friday night's video and our Master Series. This is the 46th video in our Master Series, the 16th video in our first phase processing, and the 5th video in looking at effects. Tonight we're looking at a phaser. Now this is a really simple effect that basically is causing phase issues. It can get a little complicated in what all the thing is doing. So I do recommend you do a little bit of reading on what a phaser does. But for the most part, if I take like a tone generator here and I turn it on, I put like something like Trash 2 on here that's going to generate some even and odd harmonics, and a phaser on after that. We can look at it with a spectrometer, and we can look at it with an oscilloscope. Now with the spectrometer, you'll see there's modulations happening along the whole line, and it's sweeping back and forth. The phaser doesn't actually normally cause volume reduction, but because of it splitting the channel, that what happens is it starts shifting phase of the signal as compared to the static signal, which eventually causes some cancellation and notching. So what that's going to basically do is it's got an all-pass filter that's going to be sweeping around, and it's going to be causing phase issues of these sinusoids that are inherent all over in the sound. This is just even and odd harmonics off of a tone generator, and you can watch it depending on the range of between the low and the high, where you're setting that, and the speed of that all-pass filter, how it's going back and forth. There's different stages of it also, so you can have more stages of the filtering happening, which is going to give it more of a phaser effect, I should say, because it's multiplying the concept into more stages and the spread of those stages. So that gets a little complicated, but the basic idea of it is looking at it on a spectrogram. You can basically see that if I start building up the stages some, let's just go up to like 10 stages, you can see the modulation effect, and you can see it with the speed drop down, how fast that it's causing that modulation effect to happen to those sinusoids. You don't get to see any phase issues happening here. All you see is volume reduction because of canceling out, which basically in part notches that sinusoid so that it is causing a reduction in level. And it's going to go back and forth up across there, and depending on your speed, how fast that's going to happen. And you can see the wave of it going back and forth in the range with those all-pass filters and the spread of those filters. So, and this can have another effect that's going to cause, you can actually see the different stages flowing at different areas and at different speeds and at different spreads away from each other. So that's a very untechnical way to put it so that you can kind of understand what's happening. The best way for you to see it is on an oscilloscope. If I show you on an oscilloscope here, you see I've got a few different sinusoids that I'm showing you from this waveform. And if you're looking at these different sinusoids, what's happening? That you can see the phase of them being out of phase of each other. I mean, the phase of them is actually moving around. They're not just going up and down. They're actually, the phase of them is changing. And as you change these parameters like the speed, that actually the speed of them changing and the speed of the filters, the all-pass filters moving around, is going to have this process happen quicker. So as you do that, what is going on is it's speeding up and slowing down those all-pass filters, and they're also, or I should say, how do you say that, with their cycle. So that's basically what's happening. Their feedback's just going to feed back the original signal into it, and more times than not cause a mess. But it can have an effect of looping the signal back into it and it coming out together with what you're working on. And the number of stages is going to give it a profound, more phasey sound because there's more stages of these all-pass filters going on, and the spread of them is going to change the sound also, so that they're spread out a little farther. Depth is going to be the depth of it mixed in there to where it's at certain depths, just like wet and dry for the most part. Depending on the phaser, some phasers, that parameter, you might want to look at the instructions to find out that they don't mean something else. But most of the time, that's what that means. The biggest thing you need to understand, for the most part, that's going to be the most help for you to understanding the phaser, is that it's basically modulating the other frequencies behind the fundamental with all pass filters sweeping, and so that it's actually causing a wave effect, and they're changing in phase, and it's going to cause a reduction in their volume and a wave effect notching across there that's going to have almost a sweeping effect to some point. In some ways, it'll be a sweeping effect, but it's basically causing phase issues inside of itself. So whenever you hear phase happening, if you get two tracks and listen to the phase between, if you take one track and double it, and then you take the other track and get down, minuscule amounts, so you can really see the very beginning and notch one and take one out of phase of the other. We talked about phase and editing, how to fix that. You'll start to hear the phase effect between those two tracks, or even two sinusoids, or whatever you have. You can start to hear the phase difference of them and what that effect is. Well, in any type of a sound, what this thing tries to do is cause this to happen to all the individual sinusoids in the actual envelope of sound, which can be very confusing. And to get too in depth into it is something I don't want to do, because it would take quite a bit of time to do it, to explain it properly, in my opinion. But understanding what's happening there, you can have a pretty good understanding what exactly is happening. You can see the individual sinusoids, or a few of them, from this envelope of sound and what's happening to them. This is causing some volume reduction in some of the sinusoids, as it's causing phase cancellation, and it's actually changing the phase of them, which is going to change the actual sound depending on how those individual harmonics interact. So the long and story about a phaser is trying to say, well, if you set it just like that, with those settings just like that, it's going to have exactly this effect on the audio to your ears. Well, it doesn't exactly work that way, and you will find you can get lots of different phasers that are going to have different settings. They're going to act a little bit different, better or worse algorithms, but the basic concept of that's what's happening. It's causing the phase effect. So the basic understanding of it is to experiment with it. Experiment, understand what's happening there, and different settings are going to affect different instruments or different vocalists or different applications a little bit differently. So you might get one setting that you like that works really good on this vocal thing you did for this chorus section, but you try to put it on this guitar and it doesn't sound as good, and you got to start fussing with the parameters trying to get that sound. So that's a long story short, so that you can kind of have some understanding what's happening with it, a basic understanding of what's happening, and understand it's causing phase issues, is the auditory effect that it's having. And the other thing I wanted to address is that, just like, remember, if I forget to mention this, whenever you're dealing with any type of a processor, if you set it down to 0, that you're not getting any depth. But even slight amounts of it, I've got it set here, and it's at like a 2 something. You can barely see anything happening. I set it to 3. You can start to see something happening. You can see a little bit of modulation going on there, and a little bit of phase issues happening there. And if I turn up, I'll go up to 4 now, and I set it at 4, you can see that it's doing a little bit more. You can see it even over here. And let's go up to 5 or 6 even, and you can see it's doing a little bit more. 7, 8, 9, we'll go up to 10 or 11, and you can see that it's starting to you can actually see that it's starting to cause some other issues. So the concept here is this, in very minuscule amounts added to a track. Remember when we talked about chorus in sound sculpting? that just a very minuscule amount that you can't even tell. You sit there and put it over your track and looping area, turn it on, turn it off, and you know that it's adding some, but it's like very imperceivable. And you turn it up to where, yeah, I'm starting to hear phaser effect now. Bring it down some. Bring it down some. What's that doing? That can add this type of basically phase issue, occurrence to your audio track that might have a really cool sound sculpting effect, that you're not really looking for a phaser sound, that it's actually sound sculpting in some unique way that's adding some kind of body or texture to the sound. So always remember that no matter any type of effect you're using, that can be a huge tool sometimes, because I'll go on there and it would be really cool to have a little bit of phaser sound on that vocal or something, and I'll bring it up to where it's like, well, I've got phaser sound there. I mean, that sounds like phaser. I can see it on the oscilloscope. I know it. I start backing off to where I can't really hear no phaser sound, and I go A-B it back and forth. No, I don't know. I turn it on. I can hear a little bit of a difference. I can hear a different texture. And that texture can change with you changing the parameters around. So, and having more of an effect on it, and an enriching effect or an enhancing effect because of the change in parameters. That's very in-depth. And you'll find as you start fussing with it and as you start messing with it and experimenting with it, that you understanding that it's really altering these frequencies and causing phase issues within the sound itself. It can be a really kind of unique tool to actually do that. And remember, we talked about splitting frequencies and splitting signals, that you can affect just the fundamental or the first 4 or 6 harmonics or the tail end of it or something like that. With splitting frequencies, it's going to have another different effect for building body, like I talked about, just barely using it, or doing a serious phaser effect on the upper end and the high end, or just the low end, and not affecting it over here or somewhere else. So keep that in mind always. If I forget to mention it when we're talking about any kind of processor or effect like we're talking about now. But basically, that's kind of what's happening. I didn't get into it too deep, but it's basically causing phase issues. It's real obvious to see it on a scope, and you can see it somewhat on a spectrogram when I'm dealing with a test tone generator and adding even and odd harmonics across there, and being able to see what's going on with the scope. So you can have a pretty good understanding of it's showing you basically what it's doing. It's causing some volume fluctuations with the individual harmonics, and it's causing phase issues between them in different ways depending on how you set the parameters. So I hope that explains it. You got a pretty good understanding what's happening with the phaser, and then you understand why they call it a phaser, because it's causing phase issues, and you start experimenting with it in different ways you can use it to try to cause a phaser effect on the sound in various degrees in your processing adventure. Peace, hope, love. I hope you enjoyed the video. I'll see you in the next video when we talk about flangers.